Welcome back to Learn as you explore, your go-to place for mBot2 tutorials. If you are new here, I'm a robotics software engineer who loves helping students learn robotics and supporting teachers who teach it. Welcome back, guys. Today we're going to program the pick-and-place robot with the mBot2. We saw the logic in the previous tutorial, and this time we're going to actually implement it on the robot and test it out. Let's start with our all directions ball tracking program. And the first thing we'll do is we'll refactor out the all directions ball tracking algorithm to a separate function. To create your own function, go to mBlocks and say makeblock and name your block as track ball. Now we want to have 6 inputs into this function, and all of them are going to be numbers. So click on add input number 6 times. The first one, you can rename this as target X. Second is target Y. The next one will be scale X, followed by scale Y, and then ball X and ball Y. Now when you have these 6 input arguments, click on OK. You now have a defined block. Now if you look at our main program right here, the part that does most of the ball tracking code is within this if block that checks for ball coordinates and then commands power to the wheels to track the ball. So let's extract this part out and put it in our defined block. We do need to replace some of these variables because we will be getting them from the input arguments to the function. So instead of ball X coordinate, we will replace that with ball X. Click and drag that over here. Similarly for ball Y. Instead of center Y coordinate, we're going to use target Y and ball Y for this one, scale Y for this one, and so on. So you get the idea. Just continue replacing all the variables with the input arguments that you have. All right, the function is looking good so far. So if you've tested and played around with the encoder motor power block, you will realize that if the power is less than a specific value, like let's say it's less than 13%, the robot doesn't really move that much. In fact, you can hear the wheels being commanded, but it doesn't really move. So to make it move when the power calculated is even at a low value like that, what we can do is check if the power is between a certain range and set it to a particular value that we want. This will clamp the left power and right power values to a minimum value unless it is close to 0. If that was a bit confusing, you'll understand right when we implement it now. So what we want to do is check if left power is between 0.5 and 13 and set it to 13. And we'll do the same thing for right power as well. So get an if block. Let's move the encoder power block below. Since we want to check if it is between 0.5 and 13, we'll use an AND block first to start. And here's the first condition, and here's the second condition. The first condition is greater than 0.5, so we'll use a greater than block. And we want left power to be the first operand here, and we want to check if it is greater than 0.5. And then we want to check if it is less than 13, so grab a less than block. Let's duplicate the left power block and set this to 13. Great, so now we have the condition there. Let's put it into our if block. And if this case is true, we want to set left power to the value 13%. We can do that by going to variables and bringing the set block over and set this to left power, make the value 13. Great, so now what this means is whenever the power that we compute here for left power is between 0.5 and 13, we will set it to 13. So if the robot is very close to the ball, then the power computed will be less than 0.5%. And in those cases, the robot will stop because the power value is very low. But if it is between 0.5 and 13, we want the robot to move, so we'll set it to 13 here. We can duplicate this block and add it below. Let's get rid of the extra encoder motor block that came in as a result of the duplication. And now instead of left power, we want to set all of these 3 values to right power. Get rid of this one as well. Let's grab the right power, duplicate, insert, duplicate, and insert. And finally change this to right power as well. Okay, great. We now have the trackball function defined. This will perform our ball tracking. If you remember, we moved the entire ball tracking code from here right after setting ball Y coordinate. So we should call the new function right here. To make the function call, go to mBlocks and use the trackball block. As we know, the order of arguments are target X, target Y, scale X, scale Y, ball X, and ball Y. In our main program, we want to rename the variables center X coordinate and center Y coordinate to target X coordinate and target Y coordinate. How do you rename a variable? Go to variables, right click on the variable that you want to rename and say rename variable. And now instead of center X coordinate, I'm going to call it target X coordinate. Similarly, instead of center Y coordinate, I'm going to rename it to target Y coordinate. So let's make the function call with our variables. So the first variable is target X, second one is target Y, third is scale X. Since we haven't used the scale X variable anywhere, let's go to variables and use the scale factor X block here. The next is scale Y. Go to variables, select scale Y, and then we have ball X and ball Y as the next variables to send to the function. So get ball X, and finally we have ball Y. Let's move this over a bit. We can get rid of any extra variables that we have lying around. All right, so now what we've done here is functionally not change the code a lot. We've simply refactored it so the code is cleaner and we can build more into our main program right here. Since we are done with the ball tracking function right here, we can move it out of the way just so we have some space to work with. And once again, get rid of the extra variables. Let's move this over here to make some space. At this point, let's bring up our logic from the pick and place first tutorial. According to the logic, the first thing we want to do is make sure that target X coordinate is 158, which it already is, so that's great. We can leave that alone. Target Y should be 200, so let's change that. And once we're inside the forever loop, we want to check if the absolute value of target Y minus ball Y is less than 3. So let's bring in an if block, go to control and use an if then else block. Let's move the ball tracking part out for now. Since we want to check if the absolute value of target Y minus ball Y is less than 3, let's grab an absolute block from operators. Here we see that there is an absolute of block. We'll use that. And we want to check if it is less than 3. So let's grab a less than block. And the second operand is going to be 3. The first operand is going to be the absolute of target Y minus ball Y. So since we want a minus, let's go to the operators block again, grab the minus block from there. The first operand is target Y, so we can duplicate the target Y block. And the second operand is ball Y. You will notice that we haven't yet set ball Y in the program thus far. So what we'll do is take the ball Y block from here and duplicate it, and we'll set that before we start the forever loop for the very first time that ball Y isn't set. Let's put this back together just so we have it in one piece. And now we can get ball Y from variables. Grab that and drag it into the second operand, and we're done with this condition. So let's grab that and put it into our if block. We now have if absolute value of target Y minus ball Y less than 3. Just like we had designed in our algorithm in the previous tutorial. If it is less than 3, the first thing we want to do is stop the motors. So go to the mBot2 chassis category and grab the stop encoder motor all block. So once the motors are stopped, we then want to close the gripper. If you remember from our previous tutorial, all we need to do is to set the angle to 140 degrees. Before we close the gripper, let's add a wait 1 second block. And then in order to close the gripper, we need a servo block, and the servo blocks are in the mBot2 extension ports category. So click that and use the set servo angle block. Here we want to set only the gripper servo's angle and not all the servo's angles. So select the gripper servo. I've connected my gripper servo to S3. So I want to click that. And I'm going to set the angle to 140 degrees so that it closes. Let's add another wait block, but this time only for half a second because the servo is already closed. And once we've waited there, let's do our turn and play audio. To turn, use the mBot2 chassis category and the turn until done block. Here I want to turn right, but if you want the robot to turn left, feel free to keep it that way. I'm going to turn around, so that's 180 degrees. And now we want to play the audio, for which you go to the audio block category and use the play until done block. I like the level up tone, so I'm going to use that. And once we've done the turn, all we need to do is drop the ball, which means open the gripper. To open the gripper, we use the same block, but we set the angle to 90 degrees. So let's do that. Set servo angle block and set it to 90 degrees, but we only want to set the servo S3. At this point, we're pretty much done with our objective. So what we'll do is end the program. To end the program, we have to exit from the forever loop so that the program can end. To exit from the forever loop, you can use a break block. Drag that onto your program just below the set servo open. Finally, in the else part, we want to continue doing ball tracking, so we'll drag this part into the else. Before we do ball tracking, we also need to make sure that the gripper is open. So what we'll do first is check if it is not open and open it if that's the case. So to check if it's not open, grab an if block again. Now we don't want the ball tracking to be within this if block, so we'll move that outside. And we want to check if the servo angle is not 90 degrees to check if it's not open. To do that, grab a not block from operators, and then we want to check if it is not equal to 90 degrees. So then grab an equal block. We want to check 90 degrees, so change that to 90. And finally, we want to check the servo's angle. To do that, once again, it's in the mBot2 extension port and use the servo current angle block. We want to check S3, so select that. So if the servo is not open, or if the gripper is not open, we want to open it. So we want to command a 90-degree angle to the S3 servo. But wait, we already have a block here, so we can simply duplicate that and insert it right here. Let's get rid of the break because we don't need that here. And finally, before we command the 90-degree angle to the servo, let's wait for 1 second. All right, we're almost done with our program. We have some finishing touches to do, so let's just go through them. In the beginning, when the robot starts the program, we want to make sure that the gripper is open. So once again, go to mBot2 extension port category and use the set servo angle and set the S3 servo to 90 degrees. We can also add a wait here just so the robot starts moving after the servo has opened up. And finally, when we press button A to end the program, we can once again open the gripper so that it doesn't remain in the closed position after the program has ended. So use the set servo angle block and you make sure that you're selecting S3. And that is all there is to it. Look at how much you've built. You took the ball tracking code from our previous tutorials and then built on top of that a pick and place robot along with ball tracking. That is truly impressive. I'm sure you're excited to try this out on your robot. So first connect the robot and then click on upload code to upload the program. Great. Now all there is to do is to go test it out on our robot and impress our family and friends. Let's go and start testing it now. If you're a passionate teacher and want to make teaching robotics with mBot2 easier, check out the educator packs I've put together, linked in the description. It's on my Gumroad page, and you also have a free lesson pack to check out before you make a purchase. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.